Welcome to another deep dive, everybody. Today, we're doing something a little different.
Yeah.
Tackling a listener request. We're talking HMP hardening.
Right.
And that is basically how to protect facilities from a high-altitude electromagnetic pulse,
Yeah, a hempy.
a HEMP, the kind of electromagnetic surge that a nuclear explosion high in the atmosphere could cause.
Right.
And our guide for this is going to be this fascinating document, the DoD's very own Electromagnetic Pulse Protection Manual.
The military knows how to do this stuff.
Yeah, I could do. And we're going to figure out how to break it down for you today.
We'll break down the jargon.
Yeah, we'll give you the key takeaways so you can be thinking about what kind of devices and measures you need to think about if this ever becomes a concern.
Right.
So if you want to actually see the full manual for yourself, Rafi has it available on his link tree.
Awesome.
You can grab it at linktr.ee/Ockens.
Nice.
Okay, let's start with the basics. What exactly is a HEMP? It sounds like something straight out of a science fiction movie.
Kind of is, except it's real physics. A hempy is basically a massive burst of electromagnetic energy created by a nuclear explosion way up, high up in the atmosphere.
So we're not talking about a ground level explosion.
No. Because it's so high up, the area that it would affect is huge.
What?
You could be talking a whole continent.
Oh, wow.
And that pulse itself, even if the explosion is far away,
Yeah.
it can induce incredibly powerful surges in anything that conducts electricity.
Mhm.
Think power lines, think the wiring inside your electronics.
So it's like a supercharged power surge,
Yeah.
but on a massive scale.
Yeah.
And that's why this manual even exists, right?
Yeah.
To protect critical facilities from these potentially devastating surges.
Right. And the DoD takes it seriously.
Yeah.
This manual actually has a number MIL STD 188-125A.
Wow.
And this outlines their standard approach to what they call low-risk HEMP hardening.
Low risk. That sounds promising.
Yeah, it is promising.
And does it involve?
You can think of it like building a really, really good Faraday cage.
Ah, the Faraday cage.
Yeah.
Isn't that the classic science experiment where you put your phone in a metal box
Exactly.
and it can't receive calls?
Yeah, exactly. Except we're scaling that up to entire facilities.
Oh, wow.
So you're creating this continuous metal shield around a building, and you're sealing up any gaps or openings where that pulse could get in.
So no cracks in the armor, so to
That's
speak.
right.
But buildings need doors, they
Mhm.
need vents, power lines, data cables, all sorts of things coming in and out.
You got it.
How do you deal with that?
That's where the concept of points of entry, or POEs, comes
Yeah.
in. The manual goes into a ton of detail about how to minimize and protect each type of POE.
I'm guessing they have specific strategies for each type.
Absolutely. They categorize them as architectural, mechanical, and electrical, and each one needs its own approach.
Okay, cool.
Let's start with architectural POEs.
Okay.
These are things like doors and vents.
Okay, so how do you make a door EMP proof?
So for smaller openings,
Yeah.
you got to create what they call electromagnetic closure. So picture a door with special gaskets and conductive materials, all forming an airtight seal.
So even the tiniest gap could be a problem.
Oh, yeah, definitely.
Wow.
And for larger openings, like you have big equipment access points or ventilation shafts, they use what they call waveguide below cutoff.
Waveguide below cutoff. Okay, you're going to have to break that one down for me.
Think of it this way. You're trying to fit a beach ball through a straw.
Okay.
If the opening is too small, the ball's not going to go through right.
Yeah.
So in this case, the beach ball is the electromagnetic wave.
Okay.
And the straw is a specially designed funnel or waveguide that's too narrow for the waves above a certain frequency to get through.
So they're basically building an EMP filter into the structure of the building.
You got it.
Clever.
And they use that same principle for mechanical POEs as well.
Okay.
So think pipes.
Okay.
Manual is super specific about this.
Oh, yeah.
Continuous metal piping, no gaps, no dielectric lining.
Electric line.
So we're talking about things like plastic or rubber coatings that could interfere with that waveguide below cutoff.
Okay.
They even specified the dimensions of those pipes to make sure they're filtering those waves.
They really don't mess around, do they?
Not at all.
What about the trickiest ones? What about the electrical POEs? Those seem like they'd be a nightmare to protect.
They are a challenge because you need to allow electricity and data to flow while still blocking the EMP.
Yeah.
So their solution is a combination of transient suppression and attenuation devices.
Okay. Translate that for us non-engineers.
Think of it this way. A transient suppressor is like a super strong surge protector.
Okay.
And it's designed to clamp down on those sudden spikes in voltage and current that are caused by EMP.
So they sacrifice themselves to protect the equipment further down the line?
You could say that.
Okay.
And then the attenuation devices act like filters.
Okay.
They weaken the signal strength of whatever gets past the suppressor.
That's as like a 1-2 punch. And they use these for all kinds of electrical lines.
Yeah, power lines, data cables, antenna lines, you name it.
I'm guessing they test these pretty thoroughly.
Oh, yeah, you bet. They use what's called a Norton source to simulate a HEMP and make sure those devices can handle it.
Norton source. What is that? Like a mini EMP generator.
It's essentially a way to inject controlled electrical pulses into the system.
Oh, okay.
So you're mimicking those intense surges.
Okay.
And they test with different waveforms and amplitudes, too, just to
Okay.
make sure it's robust.
It sounds like they've thought of everything.
Well, almost everything.
Oh.
There's an interesting exception in the manual.
Okay, tell me.
It turns out that buried or very short metal conduits
Okay.
for things like control and signal lines
Yeah.
don't need additional protection.
Really? Why is that?
Seems that being underground or keeping those conduits short naturally limits the impact of the EMP on those lines.
So sometimes the environment itself provides a degree of protection.
It can't, yeah.
That's fascinating. But what happens if you have a piece of equipment that absolutely can't be shielded? Like that needs to be exposed for some reason.
Right, so in that case, they use special protective measures,
Okay.
and that's like building a mini Faraday cage.
Oh, so a fortress within a
You
fortress.
got it.
Wow.
It makes sure that even those exposed systems get that extra defense.
Okay, so they've built this amazing shield.
Yeah.
Protected all the entry points. How do they actually know that it works? Do they just wait around for a real EMP and hope for the best?
No, they don't.
Okay, good.
Testing is huge.
I bet.
They have 3 main types.
Okay.
Quality assurance testing during construction,
Okay.
acceptance testing after construction is done,
Uh-huh.
and verification testing once the facility is up and running.
Wow, so they're constantly monitoring and testing things even after everything is built.
Absolutely.
Wow.
You got to make sure that protection is robust and reliable.
Yeah.
And they use some interesting techniques for this, like injecting simulated EMP pulses directly into the lines.
Okay. And they even bathe the whole facility in electromagnetic waves.
Wait, hold on. Bathe the facility?
Yeah, it's called continuous wave immersion.
Oh, okay.
They use these carefully placed antennas to create a controlled electromagnetic field around the building.
Okay.
And then they measure how well the shielding is working at every point.
So they're basically giving the building an EMP scan to look for weak points.
You got it.
That's really interesting.
It's one of the many ways they make sure every inch of the facility is protected.
Okay, this is all incredibly thorough,
It is.
but I have to imagine that even the best defenses need maintenance over time.
Yeah.
What happens if equipment wears out or you need to add new technologies? What do you do?
You're right. EMP hardening is not just a one-time thing.
Right.
The manual stresses how important it is to have a hardness maintenance and surveillance program, or HMHS.
So regular checkups for your EMP defenses.
Exactly. Regular inspections,
All right.
tests, repairs, replacements.
You want to make sure that EMP protection stays effective over the life of the facility.
So it's like having a personalized maintenance schedule for your EMP protection system.
Yeah, exactly.
Fascinating. So we've talked about the shielding.
Yeah.
We talked about the POE protection. We talked about all the testing.
Right.
But what should someone actually DO if they think a HEMP is about to happen?
Ah, that's where pre-event procedures come in.
Okay.
That's a great segue to part 2 of our deep dive.
Okay, awesome.
We'll cover exactly what those procedures entail.
Can't wait to hear what they recommend. Stay tuned, everybody.
Stay tuned.
Welcome back to our deep dive into HEMP hardening. So we've built this incredible fortress,
Yeah.
tested it thoroughly,
Yeah.
and we've got our maintenance plan all set.
Right.
But what happens when that alarm starts ringing and you think a HEMP might actually be on the way?
Uh-oh.
What do you do?
This is when those prevent procedures we mentioned earlier become really important. It's all about being prepared and knowing exactly what steps to take to protect yourself and the people inside.
Okay, so walk us through those steps. What's the first thing you do?
The manual really emphasizes early warning systems.
Okay.
Now, we're not talking about some sort of futuristic EMP radar,
Yeah,
but rather staying informed through official channels.
got it.
So think government announcements,
Uh-huh.
emergency broadcasts,
Okay.
anything that might give you a heads up about a threat.
Okay, so pay attention to the news and heed any alerts or warnings.
Yeah.
Got it.
But let's say you get that warning.
Yeah.
What's next?
Yeah, what do we do?
It's time to put your pre-event plan into action.
Okay.
And that plan is going to look different depending on your level of preparedness.
Okay, let's start with like a high-tech scenario.
Duh.
What would a facility with full DoD level hardening do?
They'd go into full EMP lockdown mode,
Okay.
think activating backup power systems,
Okay.
isolating those critical pieces of equipment we talked about earlier, and securing any potential points of entry, even those that are usually protected.
Wow, so it's like battening down the hatches,
Uh-huh.
creating this isolated bubble within a facility.
Exactly. But even if you don't have that level of protection,
Yeah.
there's still things you can do.
Like what? Give us some tips for the rest of us who might not have a bunker.
Well, one of the simplest things, and this is advice straight from the manual,
All right.
is to unplug your sensitive electronics.
Oh, really?
Yep. Disconnect power cords, data cables, antenna lines, anything that could provide a pathway for that EMP surge.
So you're basically creating an air gap, physically disconnecting.
Exactly. And it's a surprisingly effective technique, even against something as powerful as an EMP.
Wow.
And if you can turn off your main power breaker,
Okay.
that adds another layer of protection.
Makes sense. What about those backup power sources we discussed earlier? How do those fit in?
They become essential if the grid goes down,
Yeah.
which is a very real possibility after a large-scale EMP.
Right?
Having a generator, a battery-powered inverter,
Okay.
even just some charged batteries can let you power essential equipment.
Yeah.
Things like communication devices,
Oh, wait.
medical devices.
So it's all about having a plan B for power,
Right.
a way to keep things running if the main system fails.
You got it. And don't forget those spare parts and tools we talked about.
Oh, yeah.
If those protective devices take a hit.
Yeah, those suppressors, the surge arresters.
Yeah, you want to be able to replace those quickly.
So preparedness isn't just about the initial setup.
Right.
It's about thinking ahead and having the resources to keep those protections up.
Absolutely. It's an ongoing commitment.
Yeah.
And speaking of ongoing, what happens once the immediate threat has passed?
Oh, that's a good question.
What does recovery look like?
Yeah, I imagine it'd be pretty chaotic. What does the manual say about that?
Well, it stresses that post-event procedures are just as crucial
Okay.
as the pre-event steps.
Uh-huh.
And it all starts with damage assessment.
Okay, but how do you even begin to assess damage from something as inevitable as an EMP? I mean, is it as simple as seeing if things turn on?
It's definitely more complex than that. You need a systematic approach, a deep understanding of how the systems work,
Yeah.
and the right testing procedures.
So you're not just flipping a switch and hoping for the best.
Not at all. You need to know what to look for, how to test each component,
Mm-hmm.
and how to determine if something is truly damaged or just temporarily out of whack.
Okay.
And that's where those detailed checklists in the manual come in handy.
So you're not just randomly poking around. You're following a protocol.
Exactly. And remember those spare parts we talked about.
Yeah.
Having those on hand is crucial during this phase
That's good.
because you might need to repair or replace what's been damaged
Okay.
to get those critical systems back online.
So it's all about being resourceful and having those backups in place.
Right.
Okay, so you've assessed the damage. Now what? What's the recovery process like?
It's about prioritizing, focusing on the most essential systems first.
Okay.
Think communication networks,
Huh?
power grids,
Okay.
healthcare facilities.
Right, the stuff that's essential for basic functioning.
Exactly. And that's where those backup systems really come in handy.
Yeah.
Having alternative power sources,
Okay.
redundant communication methods,
Yeah.
these can make all the difference in getting things back up and running.
Right, it's all about minimizing disruption,
Uh-huh.
getting back to normal as quickly as possible.
Exactly. But the manual actually goes beyond just the immediate recovery.
Okay.
It also talks about long-term resilience, learning from the event,
Okay.
and adapting your HMP protection strategies for the future.
So it's a continuous cycle.
Is
Preparation, response, recovery, and improvement.
exactly. And this brings us to a really interesting concept that the manual talks about,
Okay.
something called residual internal stress.
Residual internal stress. That sounds intense.
Yeah.
What is that?
It refers to the electromagnetic energy that, despite your best efforts, manages to penetrate your shields and protective devices.
So even with all that shielding, some of that EMP energy still gets through.
To some extent, yes.
Wow.
You can think of it as the echo of the EMP,
Okay.
lingering within the protected space.
Yeah.
But the key is to ensure that this residual energy is below the level that could cause damage.
Got it. So it's like making sure that any EMP leakage is just a trickle, not a flood.
Yeah, exactly. And that's where things get really specific.
Okay.
The manual goes into great detail about how to measure and control this residual stress.
Okay, color me intrigued. How do they measure something as invisible as that?
They use a combination of calculations,
Yeah, yeah.
simulations,
Okay.
and those testing procedures we discussed.
Right.
It's a very precise process
Wow.
where they consider the equipment being protected, its sensitivity to EMP, and the whole configuration of the shielding.
So it's like fine-tuning the defenses.
Right.
Finding that sweet spot between protection and functionality.
Exactly. And getting that balance right is essential for making sure a facility can operate even after a SHMP.
This is all incredibly insightful.
It is.
But I have a question.
Yeah.
What does all of this mean for the average person?
Yeah.
Most of us don't have access to DoD-level shielding and testing.
Right.
What can we learn from this?
That's a great question and a perfect lead-in to the final part of our deep dive.
Okay, great.
We'll explore what we as individuals can take away from this document.
All right, excellent. We'll be right back.
Welcome back to the show. So we've spent this deep dive looking at how the DoD thinks about HESH-MP hardening.
Right.
And it's a lot.
It is a lot.
They go into so much detail.
Yeah.
But as we were just talking about,
Yeah.
what does all this mean for the average person?
Right, because most people aren't building Faraday cages around their houses.
Exactly. And most of us don't have access to all this fancy equipment and testing.
Right.
Can we even learn anything from this manual?
Yeah, I think this is where it gets interesting.
Because I think the manual offers a valuable shift in perspective.
Okay, I'm listening.
And it's about awareness and preparedness.
Okay.
But maybe on a different scale.
Good.
The manual really highlights how interconnected everything is.
Okay.
Like if the power grid goes down, that can lead to so many other problems.
Right, it cascades.
Exactly. So while we might not need a military-grade Faraday cage at home,
Yeah.
thinking about backup plans becomes really important.
So applying those same principles of redundancy and resilience,
Yeah.
but in a way that makes sense for everyday life.
Exactly. Like, imagine if your phone, your computer, your internet all went down at the same time.
Oh, gosh.
How would you communicate?
Yeah.
What about medical devices that rely on electricity?
Right.
The manual makes you ask those what-if questions.
Yeah, it's like a thought experiment
It is.
about vulnerabilities.
Yeah, how would you deal with it?
What could you do? What are some practical steps?
Well, you could keep important data backed up offline.
Okay.
Have a plan for communication if the cell towers are down.
Right.
Even just having some cash on hand in case ATMs aren't working.
Oh, that's a good point, yeah.
Just little things.
So it's not about being paranoid.
No.
We're building a bunker.
Right.
Just a little foresight.
Yeah. A bit more preparedness.
Okay.
And then on a bigger scale,
Yeah.
the manual also makes you think about supporting efforts to make our critical infrastructure more resilient.
Okay.
Like pushing for better grid security or advocating for redundant systems in hospitals.
So we can all do our part.
Yeah, exactly.
It's like that old saying, an ounce of prevention is worth a pound of cure.
That's it.
Taking those small steps now to avoid bigger problems later.
Right. And for those who want to go even deeper into this stuff, I highly recommend checking out the full manual.
Yeah, it's super fascinating.
Yeah, you can find it on Rafi's Linktree.
That's right. You can grab a PDF copy at linktr.ee/talktons.
It's a dense read.
It is, but it's really interesting.
Yeah, it really shows you how much thought and planning goes into protecting against something like this.
Yeah, it's impressive.
Who knows, maybe you'll even be inspired to make your own mini EMP-proof box for your electronics.
That's a fun weekend project.
Yeah.
But really, this deep dive has been eye-opening.
It has been.
It's a reminder that even though this might seem far-fetched, being prepared is never a bad idea.
I agree. It's all about understanding the risks,
Yeah.
taking reasonable precautions, and having backup plans.
And maybe some of these principles can even help us deal with those smaller, everyday disruptions that happen in life.
Absolutely.
Well, on that note, I want to thank you for joining us on this journey into the world of HEMP hardening.
Thanks for having me.
And to our listeners, stay curious, stay informed, and stay resilient. We'll see you next time.